I have released the quiz on big ideas, which means you can go and look at your score. Now, I don't see your side of big ideas, but I do know that, like I said, I collected it and then I released it actually last night. So you can go ahead and look at it and see what your answers were. So if you're going to do the retake, I expect you to take notes and follow along with what we're doing here, and then ask questions where you need to so that we can practice here. The first 4 questions were all on section 9.1, and that was on the Pythagorean Theorem. So I'm going to assume we all remember a squared plus b squared equals c squared. Like right here, the legs are the a and the b. The hypotenuse is always c. So I also assumed you would have a calculator with you, so you could do this as calculator work. So you end up getting x squared equals 100 and x equals 10. That's the answer that goes here. Now, the second part of the question, that was half a point. The second part of the question says, the side lengths either form or don't form a Pythagorean triple. We didn't do a lot of practice in the notes for the triple. And if you don't recall what that means, we're talking about these 3 numbers right here. 3, 4, 5 is a common triple. 5, 12, 13, 8, 15, 17, and 7, 24, 25. If you recognize these 2 legs and hypotenuse, then you don't have to go through and do the Pythagorean theorem. You will always get this ratio of sides. So what I noticed on number 1 is that 24 is 2 times 12, and 26 is 2 times 13. So that means that this is the common triple, and the third side will be 2 times 5. 2 times 13, 2 times 12, 2 times 5. That's why I know I recognize this as a triple, and that's why your correct answer would be does form a Pythagorean triple. So that's a ratio, okay? There's a lot more triples, but you need to be familiar with these 4 in particular. Those are the only 4 I will be putting on my quizzes. Questions? Okay, so put your hand up or unmute yourself if you do have a question. Number 2. So number 2, you had to drag the answers here to see which ones are which. And the same thing here, you're going to do calculator work. You take the 2 smaller legs and you square them and add them. And so these 2 here, this one and this one, have that relationship where if you square the legs and add them, it equals to the hypotenuse squared. So you get 208 equals 208. You also should have recognized this is the one from number 1. Okay, so you just answered that one. Yes, that one goes up to right triangle. This one here, 8, 12, that one goes to right. And then these 2 did not work out that way. I got 26.01 does not equal 27.04, and this one, 106, does not equal 108. You can do that all on your calculator. And there's one other thing I wanted to point out here, because what I have noticed in my many years of teaching is this right here is a pitfall that I see many students falling through. This one and this one. And they don't somehow remember that 4 times the root of 13 squared means 4 times the root of 13 times 4 times the root of 13. And so that's 4 times 4 gives you 16. And this turns into 13. This gives you 208. Same thing here. This is 6 times 6, and this is root 3 times root 3. So you get 36 times 3. If you do it on your calculator, okay, I did 4 times root 13, and then I squared it, and I got 208. So you don't have to be super great at that skill, but you do need to make sure. So look at your thing. If you got a 12 here, you know, if you did 4 times, or if you got a 52 here, 4 times 13 instead, then you just forgot to multiply your 4. Or here, if you got like 6 times 3, 18. And that's an algebra error, not a trig error. Okay, so that's number 2. And each one of those was worth a 1/4 point. So if you got a 1/4 point on your score, I rounded it up to a half or a whole. I didn't bother with 1/4 points. Same thing on number 3. We're still in section 1, where on these notes, if a squared plus b squared equals c squared, then it's right. But if the sides squared are greater than the hypotenuse, it's acute. If the side squareds are less than the hypotenuse squared, then it's obtuse. So this is directly related to this problem. For each one, you had to drag them over. This one was acute, 9, 4, and 16. These two here, no, these 3, this one, and this one were all right because it's a squared plus b squared equals c squared. And this one was obtuse. So that's that relationship. Also, if you recognize this, again, you don't have to because you would work, but this one here is a triple. And I recognize that because 21 is 3 times 7, 72 is 3 times 24, 75 is 3 times 25. And again, that's one of my triples. So it's just a little sort of shortcut for you to recognize a right triangle for what it is. But your calculator would have worked too. Any questions on number 3? That did take a lot of work. That was a tough problem, okay? And again, you were given partial credit for some of those. Number 4 was, now we're into section 2. Okay, we talked about special right triangles. Yesterday and the day before I told you to make one of these. Did you make your card yet? Where you have your special right triangles? It could just be even a piece of paper or a colored piece of paper. But you need to memorize these special right triangles. This one here looks like this. This is a 45, 45, 90. And I know that because x and x are the same, which means the angles are going to be the same. And all it's asking you to do is tell me what x is. If the hypotenuse is 9 root 2, then x is 9. 9 root 2, x is 9. Right there. No work, just recognition. Right or wrong. Now we're on number 5. And on number 5, it's section 3, actually. In section 3, we had similarity theorems. Or section 2 still, actually. So all I did was redraw these 3 triangles, all in the same direction. So I drew this one here. I drew this one here. And then I looked at, well, how am I going to solve for x? So I noticed that these 2 sides both are labeled, and these hypotenuses are also labeled. I color-coded them. Okay, and I've always told you this. If it helps you to redraw it, then I would do that if I were you. So what I drew then is x over 8 equals 15 over 17. It would also work if you did 8 over x equals 17 over 15. And then lastly, it would also work if you did 8 over 17, in other words, leg over hypotenuse equals x over 15, leg over hypotenuse. As long as that ratio ends up as 17x equals 120, you'd get the same answer all 3 ways. But the whole point is that you have to have them in the same direction in order to see what's what. If you didn't draw them and you got it wrong, then I would suggest you draw them. Keep your scratch paper next to you. Keep these notes next to you. Okay? So that's 120 over 7. Number 6 was very straightforward. This is just a definition. You have to know what a geometric mean is. X is equal to the square root of 16 times 36. And I ended up getting 24. Just a definition, 24. Okay, number 7, again, is our, this is section 3, where we called it an altitude theorem. This is an altitude when you draw from here to here, you get that median. I'm going to do, again, color coding. And the way we did it in class was we looked at it like this. This altitude here, x, is the geometric mean between these two parts multiplied, these two products. So you write x squared equals 4 times 9. X squared equals 4 times 9. And that gives you x squared equals 36 or x equals 6. Again, it's just another theorem you have to memorize, and there's no way around, no easier way to solve for that. Okay. Number 8. Now, number 8 looks tricky because all those lines, but it's really not. Number 8 is this special triangle. And this special triangle, again from section 2, the shortest side is across from the 30, that's your x. The hypotenuse is twice x, the other leg is x times the root of 3. So on my paper here, I drew that, and I'm looking here, you were given 150 here, you were given a right angle here. So you can write, this is also a right angle, because it's vertical, and then this one has to be a 30. So if that's a 30 and this is a right angle, that has to be 60, and I have a special right triangle. In this case, I'm going to turn the paper. Across from the 30 is a 5, so that means the hypotenuse is 10. If this short side is a 5, then the hypotenuse is twice that, which is 10. And if the short side here is 5, then the other leg is 5 times the root of 3. If x is 5, the other leg is 5 times the root of 3. And those are the answers in simplest form that you would have had to put in to get full credit. Again, if you got one of them, you would have gotten 0.5. Questions? Okay. Number 9 was only tricky in the wording. This is also a special right triangle. Do you recognize it? Part of it is just recognizing it. It's okay if you didn't. That is why there is a retake. But if you did recognize it, this is 60. This is your square root. This has to be 30. And your x, which is what you're looking for, it says you're looking for from here to here. Okay, but you need to find this short side in order to find this side. So if this is the hypotenuse, then 36 is twice x. That's why I wrote 36 equals 2x. So I first solved for x, which is the short side, and then the h, the other leg, is 18 times the root of 3. There's no other work. It's just that. Also, as I'm reading, I underline the important stuff, to help me see what it is that I need to do. And if the one problem with this being virtual is that, you don't have a piece of paper to mark up. But again, if I were you, I'd be writing these things down. I'd be using my notebook. I would be sketching them and using highlighters. Anything that will help me get it correct. Because nobody else is watching you. Do whatever you need to do to get it right. Okay? And finally, number 10 is the trickiest. So I'm going to take a little time on this. You want to determine the height of the screen at a drive-in theater. You use a cardboard square to line up the top and bottom of the screen structure. The vertical distance from the ground to your eye is 5.5. So that's what right here. The vertical distance is 5.5. So I colored that in pink. The horizontal distance is 14 feet. Okay, so the horizontal is 14. Try to color code this as much as possible. The bottom of this screen is 6 feet from the ground. 6 feet from the ground. So I actually marked that here. 6 feet from the ground. approximate the height of the screen to the nearest tenth. So what I'm looking for is this length right here. Okay. Now, if you look at the triangle, it's not drawn to scale. The triangle is from here to here to here. And this is that theorem I was just telling you about before, that 14 squared is equal to this pink one times this blue one. 5.5 times what I labeled as x. 5.5 times x. So this is the work. 14 squared equals 5.5x. I solved for x to get 35.6. Now, I know a lot of you got that answer. And if you put in that answer, your work is correct. You didn't answer the question being asked. Okay, so it had nothing to do with whether you did it right or not. You did it right, but the question is approximate the height of the screen. You found from here to here, which is not the height of the screen. You found from here to your eyes, but the screen is 0.5 above that. So you'd have to take this blue height and subtract 0.5 because that's a little higher. Okay, so the screen only is 35.6 minus 0.5. Screen only is 35.6 minus 0.5. And so if you put this as your answer, it would have been marked correctly. But 35.6 didn't even get you partial credit. It was right or wrong. Okay, so at this point, I'm going to ask for questions. That was 17 minutes of your time. Remember, your retake will have at least 5 of these on it.